we've just seen that if we have a constant or linear polynomial function, the graph is a straight line. It's a non-vertical straight line. So if instead of doing this I work backwards, if I give you a straight line with some information about it, can you determine the function which has it as a graph? So that's what I want to do here, or at least write down some equation which describes the straight line. So this is slightly tangent to our main goals, but it's a useful thing to know how to do. So I want to talk about something called point-slope formula, or the point-slope form. Of a straight line. So this is a really important thing to know. So let's start off with some incredibly elementary geometry. So if I give you a point, given a point, let's write it as x1, y1, where I think about x1 and y1 as fixed constants. So that describes the position in the xy plane. There is a unique straight line through this point with a specific slope. There is a unique straight line with slope m, where m is any number at all, passing through it. So again, this is a constant. So we're passing through it. So we need to algebraically describe this. The aim, algebraically describe the line. So come up with some equation or some function which gives it. So I think we should draw a picture. So observations. So let's imagine taking this straight line, okay, and we're going to label some stuff. So let's imagine my point here, this is x1, y1, and its slope m. Okay, let's take any position on this line, anything at all, and let's label it just x, y. So I want to come up with some sort of relationship between x and y, some equation which guarantees that x and y are on this line. So if I've got this situation, what do I know to be true? Well, if x and y at least are away from x1 and y1, I know that I can apply the rise over run formula. So y minus y1 divided by x minus x1 has to be equal to m. Okay, so this is just my rise over run formula for the slope. But now I can undo this. I can cross multiply by x. What am I doing? I can cross multiply by x minus x1, and this would give me the equation y minus y1 is equal to m times x minus x1. So this is a perfectly reasonable equation which describes the straight line. It's not quite in the form y is equal to f of x for some function, but it's very close, as we'll see in a second, and it gives a perfectly valid description of this straight line. So this is called the point-slope form of the straight line. Point-slope form. It's a specific format of writing a straight line in. Now, something to say is our logic that went into it required this point not to be equal to x1, x y1, because then I'd be doing what? Well, I'd be dividing through by 0 here. But notice something kind of miraculous has happened. When I've multiplied through by everything, I've removed that problem. In particular, if I have x1, if x is equal to x1 here, that would give me 0. That would correspond to y is equal to y1. So the point x1, y1 does satisfy this equation. So it's kind of a bit of an algebraic miracle. Multiplying out the denominator feeds back in that extra point. So it's a little bit of a subtle and not hugely important observation, but it's worth pointing out. So let me kind of do an example of this, just to illustrate how it could be used to find the function which gives this straight line, or a given straight line. So you don't always need to do this, I should add. Like writing this down kind of is an equation which gives it. There's not always a necessary step beyond this. You don't need to write it as mx plus b necessarily, but sometimes you might have to. So this is an example where that's the case. Find the linear function f such that y equals f of x is the straight line. So it's always going to be a straight line because it's a linear function. Is the straight line with slope -2 passing through well, let's choose the point 2, -1. So let's just label my terms here. This is equal to m this would be equal to x1, and this would be equal to y1 if I'm using the above notation. So the beauty of this is I can just immediately swoop in with point slope form. So the point slope form is what? It's y minus y1, so that's minus 1, you've got to be very careful here, is equal to -2x minus 2. So now I suppose this would imply, this is if and only if y plus 1 is equal to -2x, distributing -2 times -2 is +4. So this is if and only if y is equal to -2x plus 3. So this is your f of x. That is the function that gives the straight line with slope -2, which passes through the point 2 and -1. Shall we just check it to make sure, in case we've made a numerical error? So check. Let's just feed in 2 and see what happens. We want to get -1, don't we? F of 2 is -2 times 3 plus 3. Losing my mind. It's -2 times 2 plus 3. I was a bit worried there. This is equal to -4 plus 3. That's equal to -1. Tick. Exactly as you'd expect. So moral of the story, if I have a straight line, a non-vertical straight line in the xy plane, and I have the slope and a point, I can immediately write down the point slope formula, and I can rearrange it if I want to get an actual function. All right, so I can actually interpret it as the graph of a function. So that's the point slope form of a straight line, very useful.